Alright lads, here is the parabola. So another year 13 calculus lesson based on the parabola for conic sections. So if I was to take some cone, right, some just your standard cone, and I took a plane on a certain angle, something similar to that, then the intersecting curve would be, hopefully you can see that, would be a parabola. And we don't focus on it too much in this unit, but I'd like you to go away and have a look at eccentricity. Okay, it's got something to do with the plane intersecting the cone there, but I don't want to get into that too much today. So what we're going to do is going to define the parabola. And so the parabola is pretty much like a satellite. Okay, so any receiving information with the satellite coming in like this gets reflected into a focal point like that. A car headlight works in the opposite way. So a car headlight would shine light against this and you'd get a really straight beam of light going out. A lot of optical illusions use the cross-section of two parabola like this with two focus points, and so you can get some things happening with light in there, like a lens you can magnify and all that cool stuff. The other thing that's quite interesting is if you had a body of mass moving through space and it came into a gravitational field of some object at the focus, it would run a parabolic course through there, and a lot of those I mentioned in like gravity assists. Okay, so something might need a gravity assist, it will come in really fast in here and it will get slingshotted out. If it didn't have enough energy to escape, it would fall into an elliptical orbit, as Earth does around the sun, or most planets do around the sun. I think Pluto has the most elliptical orbit, Pluto or Neptune. I think it might actually be, Neptune maybe. So we're going to define the parabola. So the definition of a parabola is it is a locus of points, alright, so the collection of points that are equal distance from a point called the focus and a straight line called a directrix. D-I-R-E-C-T-R-I-X, directrix. So that means that if I took any point on here, then this distance would be the same as this distance. So this here is the directrix and this is the focus. I know it's probably quite small, but I need to add some new things around here. So if I was to put that focus at A0, right, that would mean that that distance there is A. Now remember that every point on here is the same distance from the focus as it is from directrix. So this puts this line at A away as well. Let's have a look at the equation of this thing. So most of the time you've seen parabolas up this way and down this way. But now we're looking at them horizontally, just for definition's sake. So if we took a point here, xy, then I want to get the distance of that line there. Okay, I know the distance of that line there. So we know that that's x, that there is x, and that there is a. So the distance of that line is just from the distance formula. So from right-angled Pythagoras, we take the difference in x values, so x minus a squared plus the other side squared plus y squared, and that's all square rooted would give us this line here. And so we're saying that that's equal to this total length here as well. It's not drawn to scale, but that's equal to x plus a. X plus a. That's what we're saying. So let's simplify this. So let's square both sides. X plus a squared is equal to x minus a squared plus y squared. And we'll expand and simplify that. So I'm going to get x squared plus 2ax plus a squared is equal to x squared minus 2ax plus a squared plus y squared. Now notice everything that can cancel down. We can subtract an x squared off both sides and an a squared. So I've got 2ax is equal to negative 2ax plus y squared, and our last step is adding 2ax. So 4ax equals y squared, and that is going to be the equation of the parabola. So y squared is 4ax. That is the equation of the parabola. So, what can we do with this thing? Well, there's lots of neat little things about the parabola that we need to introduce, but we're just going to define some things. So we've defined that as the focus. It's a distance away from a vertex. Alright, so you guys know that from year 11 tables, equations and graphs, and the MCAT and all that algebra and stuff. And it's gone over a lot in year 12 as well. So that's the vertex. We've got the focus. And so what else do we need? We need the focal length. That's the distance. The focal length is the distance from the focus and the vertex. So the focal length in this case is a. So be careful here, because if I had a y squared equals 8x, then the focal distance is 2, isn't it? Because 4 times 2 is x, so be careful there. So it's always a, the focal length. And the directrix is always in the opposite direction to the focus. So the last thing we can do is we can actually move that. We can move the parabola. So let's just go with, we've got a definition here. It is a locus of points at an equal distance from a point called the focus and a straight line called a directrix. And so we have y squared equals 4ax. The focal length is a, absolute value of a. A length has to be the positive value, so remember absolute value. And the directrix is the line x equals negative a. So that's x equals negative a up there. We can also move a parabola around as well. So if I had some sort of Cartesian plane like this, and my parabola was up here, right? And I had a vertex, and I had a focus. Well, let's say that focus would be at x1 plus a, y1, where the focus, so the vertex is at x1, y1. So if I had moved it across x1 and up y1, then my focus would be a away from that vertex. And so this equation would be y minus y1 all squared equals 4a x minus x1. One last bit of information, or hopefully that was in the camera. One other bit of information is something quite handy, and is called a lattice rectum. Yep, I said that. So, the lattice rectum. That is, if I had some parabola, it's not very well drawn, but if I had it just centered at the origin, then the lattice rectum is a line that goes through the focus. Right, this is a nice, neat bit of math, so I won't prove it. Maybe I'll put one up at request. But that line ends at A, 2A, and A minus 2A. So the line through the focus is really interesting. And the length of the lattice rectum is 4, an absolute value, A. Right, there's 2A and 2A, so the length is 4A. And that's pretty much everything you need to know about the parabola. And I'll get into the parametric equation tomorrow. So without further ado, you guys can answer this question. Determine the coordinates of the vertex, the focal length, the coordinates of the focus, and the length of the lattice rectum for this parabola. So you could pause now, give that a shot. I'm going to go through this right now. The vertex, well, it's been moved up 2 and across 3. So the vertex is at 3, 2. And maybe it might help just to draw this a little bit. So the vertex is at 3 across, 2 up. So there's your vertex. It's positive, so it's definitely going that way. Right, it's a y squared x relationship, so it's going like that. The focal length is given by A, so focal length is A, and remember that in front of the x is always 4A, so that's 2, which means that the focus is 2 away from that point. So the focus must be at 5, 3. The focus is at 5, 3. Okay? And the lattice rectum, I'll find out what that means. It's Latin, something to do with distance. Or a straight line is 4A, so it's 8. The lattice rectum, so the length of that line there, is 8 units long. So vertex, focal length, the coordinates of the focus, and the length of the lattice rectum. It really is that easy. One more problem for you guys today. We'll come back to completing the square. Okay, I need you to write the equation of the parabola given by y squared take away 16x plus 2y plus 25 equals 0. And we want that in this standard form here. Okay, so I'm going to take y squared plus 2y, and I'm going to say that that's 16x minus 25. Get my y's on one side and my x's on the other. Now, to complete the square, I'd have to add 1. So I get y squared plus 2y plus 1 is equal to, and I have to make sure I do that to both sides, 16x minus, and that's going to be 24, isn't it? By the time I add 1. Now I can complete the square. that's y plus 1 squared. And why don't I take out as much as I can from this? I'm actually going to take out 16 because I need x by itself in there. So I'm going to take 16 x minus, and you see that that's 1.5. Not your typical factorization, I'll leave a decimal, but like I say, I want to know exactly what the horizontal movement is, and there we have it. So it's a positive relationship, so it's looking like this, and it's been moved down 1 and across 1.5. So on here it's been moved down 1 and across 1.5. So it's looking like that. So we're at 1.5, negative 1 for that vertex. And I need the coordinates of the focus. Well, the focal length, remember, is A. And we have 4A here, so that must be 4. So if that focus must be at 5.5, negative 1. So I read the question again, write the coordinates of the vertex and focus, and we're done. The vertex is at 1.5, negative 1, and the focus is at 5.5, negative 1. So that usually happens, right? Because they're on the same horizontal line through y equals negative 1. Awesome. Like that smash button.